All right, hello, welcome to session 3. We're so happy to have you all here and just continue our conversation as we go forward. And so I just want to wait for people to arrive here. All right, there's everybody. Hey, everybody. Good to see you. And I like the comments already. Learning 1% every day. Let's go. So Demir had joined us on Thursday, and he was scheduled to be here today. I got a strange email. It almost looked spammy, and I was like, is that correct? And so I reached out to him to say there might have been a question, and then I hadn't heard back. And so usually he's a regular speaker on our stage, so I kind of left it alone. But I always come prepared, and I have, thanks to the help of Claude and Notebook LM, and the help of our wonderful moderators, Usman and Lee, we're just going to pinch hit and we're gonna go forward because we are collectively leading this session, which was not our original plan. I am dropping the link for our vouchers in this session, but just give me a second. Let me just get this session started, and then we will be able to get that out there for you guys. So here we are, and this is now the vector search, embeddings, and indexing. And this is SQL Server 2025 becomes a first-class AI data platform. So you've got the steps of ingest and vectorize, store and index, scale with disk-ANN, and execute semantic search. If you are not familiar with terms such as vectorize, disk-ANN, semantic search, don't worry about it. We're here to answer all those questions for you. So from keyword matching to semantic understanding, the SQL Server 2025 doesn't move data to the AI. It brings AI into the data. So this is where we see this paradigm shift, where a legacy platform, you retrieve exact keyword matches, business logic executes externally, data is moved to the AI model, vector database is a separate system, multiple hops, multiple failure points, and credentials are scattered across services. In the modern paradigm for SQL Server 2025, you retrieve semantic intent, not just keywords. The AI executes natively inside the database. AI is brought to the data. Vector store is built into SQL Server. One system, store, embedded, index, search, and managed identity, 0 credentials in the code. And that's really important. I will say when I first started being a developer, I was using APIs, and I hadn't yet learned about .env and git ignore, and I'd get screeching, blaring alerts from Google saying, your API is exposed. Then you read stories about people who had exposed APIs and got $50,000 bills from Google. And so we don't want that. So it's really important to protect those APIs and protect those passwords. Now, I just want to say, and again, everybody's welcome here. And I know that we have people at just different ends of the learning curve. We have people who use SQL and database every single day. And we know we have people here who are just like brand new to this, but super interested and want to know more. So can we put in the chat for people who are kind of new to this, for their benefit, let's lean onto the expertise of those who have this expertise. Let's do some definitions. Vector. I'm inviting everybody, drop in the chat your best definition of a vector. And I'm going to give you a few. Drop into chat your best definition of semantic, embedding, and indexing. And we're going to go through all of that in this session. But I leave this to the moderators can jump in on this. The audience can jump in on this. Vector, anything that has scale and direction. Semantic is meaning. Okay, good. And everybody's welcome to expand and elaborate on these as well. All right, so it's a good start. We'll keep going with this. And then I similarly have the Notebook LM version of the slide, which similarly has a lot of really cool visuals that kind of show mathematically kind of how the vectors work and the embeddings work. But right now we've got more of a text-based presentation. So the data lifecycle blueprint from raw text to semantic search. Every step lives inside SQL Server 2025. So phase one, ingest and vectorization. So that you've got AI underscore generate embeddings. So store raw data text in SQL, call a registered model inline in T-SQL to produce floating point arrays, no external pipeline. Phase two is storage and mathematics, vector data types. Native vector column stores embeddings in optimized binary format. Vector distance compute cosine, Euclidean, and dot product similarity. I have a visual that's going to explain this much better. Scaling with disk ANN, create vector index, graph-based approximate index, and minimum 100 rows, disk resident, SSD optimized, full DML support, and 0.95 recall. Again, if this is new for you, that's not going to make as much sense. And then phase four is executing semantic search, vector search. So the top N with appropriate iterative where, filtering during search, not after, returns distance column, and then order by ascending. I'm actually going to take a pause on that because as much as I appreciate Claude's help in giving us this version of it, there's actually another version of this that I actually think is a visual representation that will show it much, much more cleanly. And I think will make much more sense when you see it like in a picture. So I'm just going to download that and upload that. So yeah, just adding a new slide, which I think will make a little bit more sense visually, because I think I understood it more. Okay, it's loading. It just takes a second because these are huge files. Here it is. Okay, so we can kind of switch back and forth between these two, and I think it will make a lot more sense. All right, it's processing. Yeah, I think seeing kind of how a vector looks in terms of on a graph, and you can see where it's grouping words and things that kind of are similar. And so you can see kind of how similarly categorized things are or how separate they are. And when you see that on a graph, it starts to make a lot more sense. So I appreciate Claude's effort to give us this idea in text, but I'm now going to lean on to this other visual. Oh, here it is. Okay. So this is something that we had presented in our session last Thursday. So the vector search embedding and indexing. And here again, we talked about that paradigm shift from sort of the legacy to the kind of modern paradigm. And then the lifecycle blueprint. You've got your data ingestion and vectorization, the storage of mathematics, the organization, and then the retrieval. And the specific, okay, so establishing a secure AI bridge. So create external model, registers an external AI model endpoint directly within the database schema, and centralizes and locks API keys inside the database. Eliminates the risk of exposing credentials in application code or client-side variables. So we talked about that before, how when you're connecting your SQL Server to your AI, just making sure that that is super secure and that you're not exposing any of the API keys. So that's establishing that secure bridge is step one. Now, the second thing is the native vector generation. So this is frictionless integration, a native function that calls the registered external model to generate vector embeddings directly within the SQL query. And the developer advantage, no manual JSON payload crafting, no decoding responses, just a simple TSQL function call to convert raw data into high-dimensional semantic arrays. So the native vector storage, the vector data type, so the architecture is ordered arrays of floating point values represent the semantic essence of information, and we're going to see that in the next slide. The optimization exposed to developers as familiar JSON arrays, but stored natively in an optimized binary format. And the precision is configurable dimensions, example vector 1536, for standard OpenAI embeddings using single precision 4-byte or half precision 2-byte floats. And so this is the slide I was looking for. This is when we were talking about specifically what is vector distance. This is now, what you want to be thinking about, these are words, these are concepts, these are ideas. And it's like, how far apart do they fall on a graph? So if you're talking about animals, it's like, what's a domestic animal? What's a farm animal? What's the farm machinery? Like, they're all different things. And they kind of, where do they sort of sit together or far apart, in having that idea that's the vector, the vector. So the mathematics of similarity. So vector distance, there's the metric vector 1, vector 2, and so there's cosine similarity. So it measures the angle between vectors, focuses on relative semantic direction, invariant to magnitude, best for text embeddings. Euclidean distance, which is just basically a straight line, measures straight line spatial distance, common for image embeddings. And then dot product, dot measures the sum of the products of the corresponding components. A lot of this, when it's like you use it regularly, or just in general when you start using it, it will start to make a lot more sense. So phase 2 is standardizing the magnitude. So vector norm to normalize. So normalizing the data. So vectors with different magnitudes skew distance calculations. So this is kind of looking for those outliers. So the solution is vector normalize, calculates the exact magnitude, length, and the vector normalize scales the vectors so its length is exactly 1. So the result is all vectors land on the same unit sphere, optimizing the accuracy and performance of cosine similarity searches. And so here you have the difference between exact nearest neighbor and approximate nearest neighbor. And so we'd seen that term before, DISC-AN. This is what the AN stands for, is approximate nearest neighbor. So here you have different dimensions. You've got your precision, you've got latency, how quick, fast, or how slow it's going to move, the resource usage, and the data set size. So you're going to use different ones in different scenarios. So your exact nearest neighbor, the precision is going to be guarantees 100% precision. Your approximate nearest neighbor, I mean, it's based on the word approximate, trades a fraction of accuracy for speed. So the recall is close to 1, but it's not exact. Latency, it's going to be slower because for ENN, because it requires the full table scan. And the approximate nearest neighbor, it's going to be highly optimized for millisecond latency. Resource usage, it can consume massive CPUs and I/O, whereas the ANN, it balances memory, CPU, and I/O using, or input-output, using graph navigation. And the data set size, it's recommended for rows that are less than 50,000, or recommended for data that's less than 50,000 rows, where you can use ANN, is required for production scale, million of rows. So those are things you're going to need to know. It's sort of like, when to use one versus the other. What are the benefits of one versus the other? And so organizing via DISC-ANN, so create vector index. So an algorithm, DISC-ANN, does not use B trees. It constructs a navigational graph to quickly hop towards the closest semantic match using minimal memory and SSD storage. The constraint, because it requires building complex relational web, creating a vector index requires a minimum of 100 rows with no null vectors values. Otherwise, you'll get an error message. And then the full DML support and live maintenance. So legacy limitation, early vector indexes locked tables. Data modification was impossible without dropping the index or accepting stale results. The modern standard is the latest DISC-ANN structure, provide full DML support, and that results in the operations run seamlessly. The vector index performs automatic real-time background maintenance, and the vector search is now suitable for live transactional workloads. And so here you can insert, update, delete, and merge. And so you have all of that capability. And then phase 4, executing the semantic search, the function vector_search. So you've got depreciated syntax, vector_search, top_n equals 10, depreciated throws error message on new indexes. And the modern syntax, select top 10 with approximate star or wildcard from vector search, order by distance ascending. So the requirement is the distance column is now the only valid ordering key for approximate search, and it must be ordered in ascending. So phase 4, the evolution of filtering. So here, the filtering strategy, you've either got the legacy or the modern. So the timing, it predicates applied after vector retrieval, and the timing here is it predicates applied during the vector search process. The result completeness is unpredictable for legacy, where a clause eliminates rows from initial n neighbors, returning fewer rows or an empty set. Developer fix, guessing and oversampling oversized n values. And then within the modern iterative filtering, guarantees completeness. Engine continuously searches index until exact n qualifying results are found. Developer fix, none required, it's fully native. So here you've got the iterative filtering engine, your disk A and N index, proximity leads to traditional B-tree index, the where clause filter. And then that can loop to the next candidate loop as an automatic pull. And then you get your exact n items, final results. So the query optimizer leverages both index types simultaneously. Vector index identifies proximity. Traditional index filters candidates dynamically. Discard and loop if candidate fails the traditional filter. And returns exact end results without manual tuning or query rewrites. So the synthesis is you get a unified SQL AI pipeline. So you start with you've got your user prompt, creates an external model, that security gate, then goes to the AI generate embeddings, the vectorization, that goes to the JSON context output. And again, JSON is heavily featured on this exam. You've got the disk approximate nearest neighbor, index vector search, and the iterative filter B-tree where clause. So the entire enterprise retrieval augmented generation backend lives securely and natively within a single SQL environment. So there's no middleware, no data movement, and maximum intelligence. So that is one version of this presentation, and hopefully a helpful one. I've not, because I had it so that I could sort of see the whole screen, I have not been on the chat, but I'm seeing that it looks like there are questions, and so I'm just going to come back to our session here. So we were looking at some of the slides here, and so that we got to that data lifecycle blueprint. So this is the same thing, but it's essentially we're looking at the Claude version of it. And I think that this is probably a good stopping point. I'm going to continue on, but now it's going to kind of be review. But I know you've all been very patiently waiting for like, where is our form to get our vouchers? So let's do that now. Let's take a quick break and get that done. So I'm going to go ahead and drop that. You are all going to get that right now coming through Luma. So check your Luma and you will get the form and fill that out. And I am going to, once I can, so it looks like since I and we are covering for Demir for these sessions, for this one and the next one, I'm going to be kind of busy with that. But then Ladislaw is coming back to wrap us out for session 5. And while he's on stage, I will be deploying all of your vouchers. So that is our plan. So you all have the voucher link. If you did not get the voucher link, it just means you're not registered through the Luma. So I'd highly recommend that you just register through the Luma so that you can get access to everything that we are sharing here for vouchers. I think most of you should already be registered, but I'm just going to drop that in the chat. You might have to cut and paste it, so I don't think this account is still somewhat new and may not have clickable links just yet. So if you like our channel, that's the faster that it gets to us being able to have clickable links. But there we are. So I think that was one of the questions that everybody had, and I think we've answered it. So yeah, I look forward to you. And just there's also, I sent you all some of the official Microsoft Fabric links, and they did say they'll have additional vouchers probably available for people who register for the Fabric Data Days. And so you have that link. So I would encourage you to apply there too, so you can either get vouchers for yourself or recommend it to others that you may know who are also looking to get Fabric vouchers. So that is the DP 800 link. Now, please do not fill this form if you, now that you have a sense of what's on the exam, if you're like, yep, I can crush this, or I can take the next 2 weeks and I've got this, or I'm just ready to take it. Again, the pass fail is, we obviously want you to succeed. We want to be respectful of your time, but that's not part of the guidelines. The guidelines is your name, your email, that you don't sell it, you don't give it away, that you use it and you register it for today. For today's vouchers that I'm deploying today, they must be registered today. And then you have until June 15th to take the exam. And you can only use it for DP-600, 700, or 800. Those are the compliance. So if you all stay compliant, I can get more vouchers. Yeah, awesome. Yeah, so yeah, take advantage of that. There's now like an SQL user group that I put in there. You're all welcome to, Ladislav and I both have our Fabric user groups. You're welcome to join us there. So it's all, we're all in this together because it's evolving so fast. And I have to be honest, this is one of my favorite ways to learn is in community and in groups, and not feeling like I'm totally just doing this all by myself. And I just, like I said, it's moving quickly. But it's also, I find it moves in a way that it actually compounds on itself. So sometimes it may feel a bit daunting when you don't know certain terms, or you're hearing things for the first time. But my graduate studies and my life as a university student, I kept kind of moving departments, because every time I'd kind of get to something, I'd be like, oh wait, there's more. Oh wait, there's more. But by the time I kind of got to the end of my academic journey, I saw how much stacked and how many of the concepts were universally applicable. So I'll give you an example of this. Is when I did my Google Digital Cloud Leader exam, 2/3 of it were cloud and 1/3 of it was security. When I did my ISC squared, certified in cybersecurity, 2/3 of it was security and 1/3 of it was cloud. So you find that these concepts start to build on each other, and that your knowledge actually starts to accumulate faster. So I feel like I'm prepared now for DP-800 and SC-500, which are both sort of bringing AI enablement into security and SQL. But in reality, like, we're all security people. We all should be security minded. So Fabric is great for geospatial data engineering. That's a slightly other topic because if you're working with raster data, and so just for people, okay, the term vector in this context is referring to the similarity of words or concepts that are sort of mathematically calculated. When I, as a GIS professional, use the word vector, we're actually referring to points, lines, and polygons that you can put on a map. And there's raster image that lays over like a photo, so a picture that a drone would take or a satellite would take. And so no, Fabric is terrible for, and it does not support raster images. So when I work with satellite imagery, which I do quite a bit, I do not use my Fabric. But when I do graphs and tables, when I'm working with tables and graphs and anything that's in that point, line, and polygon phase, it's amazing. And there's a lot of fantastic data now available to us through Esri. Okay, so did not receive the email with the voucher form. You would have gotten it through however you registered for the Luma event. So if you're getting all the reminders of like, hey, meet us in the next session, hey, there's this, that's what where you're gonna find the link to the form. So, and I'm specifically referring to Cynthia. So it is sent out through, so maybe I can get a show of hands or comments in the chat. Did you get access to the voucher form? If you've gotten it, can you share it and confirm that you're getting it through the blast that I'm sending out through Luma? And in the meantime, I'm also seeing this comment, which is I'm also studying for the AZ305s. This complements that. Perfect. Okay, so yeah, XR Learn, got it. So Cynthia, just make sure that you are registered through Luma. And if you're looking for the Luma link, it is in the description below. And I have also popped it into the chat. So hopefully you can. Okay, so I'm seeing some people. I guess my question to you is, are you getting the other announcements that I am making through the Luma blasts? So however you're receiving your Luma updates, that's where you should be receiving it. I have 26 responses on the form so far, which means that 26 people have found it. But clearly we have about 50 in this room. Received mine. I received the announcement but didn't get the voucher link. The last one that I just shared, actually, you're going to have to copy and paste it because you can't click through here. But I'll just go ahead and put it in the chat. But I just make sure you sign up for the Luma because all of the announcements and follow-up materials and everything else is there. So I've just dropped it as a link in the chat. So now you should be able to just copy and paste that link, and then everybody should have access to it. All right, so we have a few more minutes. I'm going to just go back to the slide because I think that this will that. Okay, so everybody should have that now. Thank you, everybody, for confirming that you got it. Thanks for everybody. I'd like to take the after the 15th, so please share those who would need it sooner. Okay, so just for full clarification, regardless of when you plan to take this exam, now or a year from now, just fill it out so that I can be in touch with you when I get the next and the next and the next tranches, or I know what actions you can take of where you might be able to find free vouchers or discounts. So everybody's invited to fill out the form. I will then go through the form, and anybody who says, I plan on taking it before June 15th, those are the people who are going to get an email with the voucher code today. And as soon as I get the next tranche, which will have new registration deadlines, new exam deadlines, I'll check in with you and say, hey, you ready to take it now? And if you say yes, I will then deploy you my next tranche of vouchers, trusting that everybody here is compliant with the guidelines. Because if they're not, then I don't get vouchers. So everybody staying compliant helps everybody else. So that's how that works. So everybody just, fill it out and just let me know which exam you're interested in taking and which ones, and when, like I said, that's how I'll divide it. So let's run through the rest of this. And again, I just want to acknowledge and thank my incredible moderators who are just doing a great job keeping everybody up in the chat and keeping a very lively chat. And I appreciate all of you. And I think many of you know me already, but I've just finished 5 years of graduate school. Now I need to pay for it. And one of my little hobbies I've decided is I'm like, I want to grow on YouTube. So if this is like content that's interesting to you, like definitely follow along. I have lots of videos from other events that we've done in the past. And the more engagement I get, the more just encourages me to do this and to be able to go to companies and groups like Microsoft Fabric and say, hey, give me stuff that I can give to my audience because I have an audience. So we all help each other. Okay, so that said, so we've established, you've got the secure AI bridge, right? So what it does, it registers an external AI model as a first-class name-based database object. The model definition lives in sys external models, just like a table or view. The security imperative centralizes and locks all API keys inside the database, eliminates the risk of exposing credentials in application code, and use managed identity whenever possible. So you'll hear words like IAM, which is Identity Access Management. You'll hear words like RBAC, which is role-based access management, so not assigned to an individual, but basically whoever sits in that position. You'll hear things like row-level security, which is literally assigned on either a role or a person who can actually see what in a table. You'll hear words like PII, personally identified information, PHI, uh, personal health information. And then the exam note, please stick around for session 5. Ladislao is amazing, and he does such a good job of breaking this down to how to optimize your study and just crush it. He has never taken an exam that he has not passed. So he is a master, and he's got great, great insight. And it's a great session. So here we are. So the exam note is create external model is a prerequisite for AI generate embeddings. Register the model first, then call with its name, and the managed identity is the preferred authorization. So the native vector generation. So kitchen remodel products, AI generate embeddings, use model my models, and then you've got the vector 1563. So frictionless integration, a native TSQL function, calling the registered external model to generate embeddings directly within SQL. So no Python, no middleware. One function call replaces an entire external pipeline. The developer advantage, no manual JSON payload crafting, no decoding base 64. A single TSQL call transforms text into a high dimensional vector. And the exam syntax is AI underscore generate underscore embeddings. Source use model underscore name. So use model keyword is required. And then phase 2, native vector storage. So the vector data types, not var-binary, not JSON, a first-class SQL type that understands its own dimensionality. And this is vector 1536. So the architecture, ordered arrays of float point values, so 4-byte single precision per element, SIMD optimized binary storage, not var-binary. The engine understands its dimensionality. The optimization exposed as vector n in DDL. Standard OpenAI embeddings use 1536 dimensions, stored in optimized binary format for fast computation. And precision options, standard 4-byte single precision floats. The preview float 16, 2-byte half precision, supporting up to approximately 4,000 dimensions, enabled via preview underscore features. And then phase 2, the mathematics of similarity. So we talked about this. The cosine similarity measures the angle between two vectors, the value range of 0 identical or to 2 opposite. Invariant to vector magnitude, best for text embeddings where semantic direction matters more than length. The Euclidean distance, we talked about, that's the straight line spatial distance between vector endpoints. The values range from 0 to infinite. Sensitive to magnitude, suitable when absolute position in vector space is meaningful. And the dot product dot measures the sum of products of corresponding components. Only meaningful for normalized vectors, the magnitude is 1. Computationally faster than cosine for pre-normalized embeddings. Phase 2, standardized magnitude. The problem, vectors with different magnitudes, skew distance calculations. A short product description and a long article produce embeddings with different lengths, making raw Euclidean distance misleading. So the vector norm calculates the exact magnitude, the L length of a vector. Vector norm embedding returns a float. So vector normalization scales the vector so its Euclidean length is exactly 1. All vectors land on the same unit sphere, optimizing accuracy and performance of cosine similarity searches. So check the magnitude with select ID vector norm, and then normalize all vectors. So all normalized vectors, magnitude 1, cosine search is maximally efficient. And then phase 3, the scaling the search space, the exact nearest neighbor versus the approximate nearest neighbor. And we've just gone through this. So this is that same information of when you use one versus the other. So exact guarantees precision, but it's slow. It does a full table scan. It's got massive CPU, input output, no index structures, recommended for less than 50,000 vectors. And, but the full DML is always supported. And then the approximate trades that fraction of accuracy for speed, optimized for millisecond latency. It balances memory, CPU, and I/O using graph navigation. And the production scale, millions of rows, minimum of 100 rows required to create the index, and full DML support in latest version, real-time automatic maintenance of GraphView index. And then organizing via disk, approximate nearest neighbor. An approximate nearest neighbor does not use B-trees. It constructs a navigational graph to hop toward the closest semantic match using minimal RAM and SSD storage. It's developed by Microsoft Research, and the recall is approximately 0.95. The constraint, it requires a minimum of 100 rows with non-null values, vector values before index creation. Otherwise, you'll get an error. And then force underscore ANN underscore only hint. Use as a table hint to force the optimizer to use the disk ANN index rather than falling back to exact KNN search. So full DML support and live maintenance. Vector indexes no longer make tables read-only. So legacy limitation from earlier versions is that early vector indexes locks tables after creation. Data modification was impossible. We talked about that. Modern standard, latest disk ANN implementations provide full DML support with automatic real-time graph maintenance. Vector search is now suitable for live transactional workloads. So you can insert, update, delete, and merge. And the result is production-ready vector workloads. And the execution of semantic search. So there's the depreciated top underscore n parameter. Now moves over to the modern select top n with approximate. So we have distance column, ordered by ascending only, iterative filtering, force ANN only, and not usable in views. And then iterative filtering engine. So again, the legacy post filtering and the modern iterative filtering. So how iterative filtering works is the disk ANN index, proximity candidates, B-tree index, where is the predicate filter, candidate loop, discard loop after it fails filter, and final results exactly n guarantees completeness. So optimizer uses both indexes, guaranteed n results. So the engine continuously loops through the candidate set until exactly n qualifying rows are found. No oversampling, no empty sets from filter elimination. And you get production-ready design, returns exactly n results without manually tuning or query rewrites. Vector search is now suitable for transactional workloads, not just batch analytics. And so the synthesis, a unified SQL AI platform, got user prompt, create external model, adds the security gate, AI generate embeddings is the vectorization, disk ANN index is the search, vector search, and iterative filter is the where, is the relative filter, and the JSON context output is that SP invoke external REST. And that brings us to the end of that session. How are we doing for time? We are right on time. So we're just going to wrap it out and let's better getting them before the end of the program. Yeah, I'm just scanning the search. Absolutely, the moderators have all of the right answers here. And I'll just kind of reiterate some of them if you're listening and perhaps just not following all of the chat. But basically what we're saying is that right now for this kind of live event, I'm keeping the registration open. And so even if you are like, no, I don't think I'm ready to take this, that's fine. Just check the box that says after June 15th, no problem. The vouchers I deploy today must be registered today. So you do need to be prepared to take that before June 15th. If you are not prepared to take it before June 15th, no problem, but fill out the form anyways, because I'm not going to leave the form open. I want to give a benefit to everybody who's taken the time to show up live. And so I will actually close the form. And then I will basically see how many vouchers I have left and reach out to people who have registered for our event, but perhaps were not able to join us live, but plan on joining the replay. And I'm just going to basically ask that they invest some of their time and energy into, making sure that they're still participating so they can get the best advantage and the best chance of actually passing the exam. So I do want to make sure that the vouchers are slightly gated. So beyond more than just registration, there's actually a participation. So I will open it again to with that sort of, hey, just show me you've participated in some way. But I would say for today, if you're here, just take advantage of it and just fill it out. And that way I know that, like I said, even if you're not ready, no problem. As soon as I get more vouchers in hand, I'll just make sure you're sort of top of list to get them. And that kind of, yeah, we're almost at time for our next session. And yeah, just really appreciate everybody being here today. And so now that we have, hopefully now this ideas of vectors and embedding and what this process is kind of starting to make more sense. Don't worry if it doesn't. Like I said, we've got lots of study resources for you and documentation and the Microsoft Learn that you can sort of go in and also make sure you're getting just even more understanding of this. This is just laying out concepts just so you can kind of understand the scope of what is covered on the exam. And so with that, I'm going to go ahead and invite us all to our next session. And we're coming into session 4. So we're going to get into retrieval augmented generation and our REST endpoints. And yeah, just appreciate you all. And feel free to drop a like on this video. That really helps the algorithm. And if you like our channel, that's cool too. And so I'm dropping in the YouTube. I'm sharing it out through Luma. So join us for session 4. And so we've got that link for the next session. And I'm just coming back to our form. Okay, I have 80 responses. That's fantastic. And I have 80 vouchers. So that'll actually have more than that. So we're good. Yeah, actually, I'm very motivated to get the ones I have out the door and effectively deployed. So yeah, that's what another thing, because I have quite a few to share. You are welcome to say before or after, like if I have, I know many of you have already filled it out, so don't worry about it. But I was going to say, passing is not one of the guidelines. So if you're just up for taking it, and you're welcome to do that. Okay, everybody, we will see you in the next session, and excited to see you there. But of course, we want you to pass it. That's why we're trying to give you as much information as we can so that you can have the most joyful experience when you take that exam and feel like you're crushing it. So we'll see you all in the next session. Thank you, everybody.